Question 24. The diagram shows a solid cone and solid sphere. The cone and the sphere has radius r, and here the slant height is L, perpendicular height is h, and the base of the base radius of the cone is equal to the radius of the sphere. Given that k multiply the volume of the cone equal the volume of the sphere, we're going to take this and write it as an equation, simplify it, and check what is the relations here. Show that the total surface area of the cone, which is pi r squared plus pi rl, equal to this, can be written in this form. So let's start with the given volume of the cone is 1/3 pi r squared h multiply k equal to the volume of the sphere 4/3 pi r cube. Let's simplify by multiplying by 3 both sides, dividing by pi, dividing by r squared. So we can find that hk equal 4r, or that r equals hk over, or we can make h here, which is equal 4r over k, or that r equal hk over 4 is the same. Then second step, I'm going to write the total surface area. The total surface area of the cone, which is pi r squared plus pi r l. So I'm going to check here the form that is written, that the total surface area is written in pi r squared k plus root k squared plus a, and a is a constant, and over k. So we have the variables here are r and k. Here we have r and l, so I need to remove l and write it in the form of r. And so what is the relation between l and r? It's Pythagoras. So we have that l squared equal h squared plus r squared, or the inverse, whatever. And then we have r squared, yes. And instead of h, I'm going to write 4r over k squared. So it's equal r squared plus 16r squared over k squared. And for the L, it's a square root of this. So let's simplify here, substitute the L with the root. So it's pi r squared plus pi r square root of r squared plus 16r squared over k squared. And we need to write it in this form. So I have pi r squared here, pi r here. We can take pi r common factor, but here it's pi r squared as common factor. So I think we need to take r squared, another r from this square root. How to take it? We can factorize under the square root, take r squared as common factor, and 1 plus 16 over k squared. Then it will be equal pi r squared plus r squared. I can take it outside the bracket. So it will be multiply r, which is pi r squared, square root 1 plus 16 over k squared. Okay, so now it's more close to this. Let's check it. So it's pi r squared as common factor and 1 plus square root of 1 plus 16 over k squared. Okay, then inside the square root, we can simplify this fraction and write it in as one fraction with a common denominator. So pi r squared bracket 1 plus square root of k squared So here it will be k squared plus 16. I multiplied 1 or write 1 as k squared over k squared. Okay. Why did that? To take k squared as a common factor outside the bracket as k, outside the square root as k. So it's pi r squared bracket 1 plus 1 over k square root of k squared plus 16. Now let's make a common denominator here, which is k. So here we can write 1 as k over k. So it will be k plus square root of k squared plus 16. And I think this is the form it's written in. Yes, k plus square root k squared plus 16 over k. And this is pi r squared. So a here is equal to 16.